Hello and welcome to our webinar. This is our first lesson, kind of an algebra 2 preview, and it is going to be basically transformations of graphing functions, and so we're going to talk about graphing functions today. This lesson needs to be watched before 4:25. So today what we're going to talk about is we're just going to get you in the idea of graphing functions. And so in this, if you want to pause it, and remember, pause it if you want to try the examples on your own. If not, just follow along with what I'm going to do. So I'm going to make a table of values for this equation here, and it says hint choose any values for x and then solve for y. So I always like to choose values of x. My favorite value for x is 0. You choose that one because it's really easy to multiply by and add, subtract to. 1 is always a good one. -1 is good. And then whatever else you want, I'll be boring and go 2 and -2. So I'm going to plug in these values into the function. So I'm going to say y equals 0 plus 3. If I simplify that, I find out that y is just 3. If I plug in 1 in for x, I get 1 plus 3. I find out y is 4. If I plug in -1, now I have my change in signs, so I end up with -1 plus 3. I owe somebody $1. I have $3. So when I pay off my owing, I now have a 2. And the whole reason for doing this is so that we could plot a graph. If I plug a 2 in for x, 2 plus 3 will give me 5. So I get 5 over here, and then my last one. And you could have picked any values you wanted. These were just the ones. I always try to pick the ones closest to 0, 0 on the graph, just because they're easy for me to multiply and add and whatever else I need to do. So I end up with +1 for that one. And so this is my table of values. And then I could plot these points, my x and my y, and that would give me my graph that I would see for this line. So we're going to move along here, and basically we're trying to ask you what kind of function this is. And since there is no exponent, so we'll go through this. If it was quadratic, there would be an exponent of 2 here, but it's not quadratic because there's no exponent. If it was linear, well, this is actually the linear graph, so we'll call it linear. If it was square root, it would have a little square root in front of it, but it doesn't. If it's absolute value, we use the absolute value symbol, which it is not. So these two are gone, even though I already told you. And then if it's trigonometric, that's where you'll see sine, cosine. So it would be like sine of x and cosine of x or stuff like that. So that's why this one is just a linear function. It'll make a line when it's graphed. So we're going to graph this function. And the best way to graph this function is to set up a t-table. And so I'm going to get some straight lines here, just like we did at the very beginning. And really you only need 2 points to make a line, but I always go with at least 3. And so I'm going to say x and y, and I'm going to make up my x's for this. I'm going to go with -1, 0, and 1. I always like to choose these 3 values because they're real close to the axes. They're easy to add and multiply and do all kinds of other things with. But sometimes these don't work very well if you're going to get fractions and things like that. So you got to choose wisely. In this case, these are a fine choice. So when I put -1 in for x, I find out that y is -1. I put 0 in for x, I find out that y is 0. And when I put 1 in for x, I get 1 for y. So now I plot these points. If I go back 1 and down 1, I end up with a point right there. At 0, 0, I have this point. And last but not least, 1, 1 would be that point. And so now I get this nice straight line. Let's see if I can hit these points. Do the best I can. So my line would look something like that, and I can extend my line so that it actually goes from end to end. And as long as I hit the points there you go. There's what my line would look like, and that's the graph of the function. That's just really what we're trying to do, is come up with graphs. So now we have a function. We are looking at this type of function, and you'll notice it looks like it's y equals x, but there is a square on it. So just like before, this is a quadratic function. A quadratic function is when x is squared. It's not linear because that's if it's just y equals x. If the x doesn't have a power on it, remember we talked about these already. So this is a quadratic function. Then it says this function. The quadratic function is created by taking the linear function and squaring it. So if I do something like that, you can see that I'm taking the linear function into the square, and therefore That's really what we're trying to get. So we're just putting in our old linear function into our function and making it squared. That's what makes it a quadratic. So now we'll graph this, and again, let me get my straight lines. And to graph this function, we're going to do the exact same thing we did before, and sometimes I might even set up another little column in my t-table for me to do my work. And I would kind of recommend for this, recommend that you do this. Just makes life a little bit easier. This is x, this would be my y, and in the middle I might put work, just to have a place to put my work. So I'm going to choose the same values I chose before. They're kind of boring values to choose for x, but they're easy to work with. So then if I want to find out what y is, I'm going to say y will equal -1 squared. So I have to think what -1 squared is. Well, that is -1 times -1, and so then y will come out to be +1. Well, if I put 0 in, 0 squared will equal 0. And y equals 1 squared will equal 1. So now I'm going to plot these points, and you might want to do a few more of this just to kind of see what's happening. I'm going to go with -2 and +2 just to get a little bit more. So if I say y equals -2 squared, -2 times -2 is +4, and y equals 2 squared would be 2 times 2, which is also +4. So now I'm going to have a pretty good look at what this graph is going to look like. You'll notice at -1, here, if I go back 1, I'm up 1. If I go 0, I'm at 0. If I was at +1, I was at +1 in the y. If I'm at -2, I'm at +4. And if I'm at +2, I'm at +4. So I get a graph that looks like this. And if I sketch in my graph, this is what the quadratic is kind of a U-shaped graph. It's what we call a parabola. And it would look something like that. And that's a pretty good sketch of our parabola. So that's what we're trying to do. So moving along, now we have this function, and really to know what the name of this function is, we need to know what these two straight lines mean. And I know, because by process of elimination, it's not quadratic, it's not linear, doesn't look like a square root symbol, so I can cross that one out. And then it doesn't have any sines or cosines in it, so I'm going to cross that out. So this thing is absolute value, and that's what these symbols, that's what this symbol really is. And the absolute value is really just a shortcut for squaring a number and taking the square root. So that's really what we're going to do. And so again, if I take this function and slide it into my other function, you'll notice I just to get my linear function, and it ends up being absolute value, something like that. So if I wanted to graph the absolute value function, I will get some more straight lines. And again, I'm going to do my 3 columns because I want to do some work in the middle there. And so let's see if I can move this guy up. It's going to move that away, so I won't do that. I have x, my work, and my y. And this time, I'm going to start with -2. I'm going to do a few more points than I did before. And just because I know what I know what this function looks like already, and so I think it'll give us a better view of what's going on, what's going on when I see this graph. So if I plug in -2, so y will equal the absolute value of -2, and if I do the absolute value of -2, I end up getting +2. Because remember, absolute value is how far away from 0 I am. I don't care if I'm in the negatives or the positives. I just want to know how far away from 0 I am. So I get 2. And then same thing here. If I put -1 in, I also get +1 because I don't care left or right. I just want to know how far away I'm 1 unit away at -1. When I put in the absolute value of 0, I get 0. When I put in the absolute value of 1, when I put in 1 into my absolute value, I end up getting, I'm still 1 unit away, so I put a 1 there. And when I put in 2 into my absolute value, I get +2 also. So I'm 2 units away from 0, so that's really all I want to know, how far away I am. So if I plot these points at -2, I'm at +2. At -1, I'm at +1. At 0, I'm at 0. And then +1 is +1 and +2. And so this graph is a little bit different than the last one, because in the last graph, this one I am, as I move up in my x's and y's, I am basically moving the same. For every x, I'm getting the same y value, and so it's not changing, so I get this nice little V-shaped graph. In the last one, let me back up real quick. In this one, you could see that when I plugged in an x value like 2, it ended up giving me 4. So it went away from the V shape, because if I would have plugged in 2, I would have gotten 2 to keep the V shape. And so this ends up giving me kind of a parabola, kind of a curve shape, where this other one over here is just a nice little V shape. So then we have